I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, February 23rd. Tonight we'll be discussing jet stream level winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean. Let's get to work. Looking at significant wave heights in the North Pacific Ocean, we see a much improved pattern. Small gale is developed off of British Columbia, producing 27-foot seas, but of more interest, a stronger gale producing 37-foot seas is over the North Dateline region and falling southeast, aimed well at Hawaii, and yet a third system is developing off North Japan with 27-foot seas aimed east. And that doesn't even count two swells already in the water coming from the southern hemisphere. So, it seems like we're in business, at least for a little while. Looking at jet stream level winds, we see an improved pattern. The jet is consolidated, pushing off of Japan with 170, one little pocket to 180 knot winds, pushing the whole way from Japan to the dateline, a small trough trying to organize over the Kuril Islands, and yet a second trough is in the northwestern Gulf, both capable of supporting gale development. That is, when you get a trough, that is a dip in the jet to the south, like right here, that helps create a counterclockwise flow aloft in the atmosphere and down at the ocean surface. And of course, counterclockwise moving air in the northern hemisphere is a sign of low pressure. Low pressure, if it's deep enough, generates winds. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. Right, so two areas of interest, and actually almost a third little trough is off the Pacific Northwest. So let's put this into motion. Oh, wait, one other point. The jet is kind of split just north of Hawaii. You see the northern branch kind of easing up here and pushing into Oregon, while the southern branch meanders down and over Baja. It is in between the split flow that you get high pressure, and that has been the hallmark almost this entire winter of high pressure in the Gulf of Alaska, or at least off of California, and that is what is contributing to the lack of rainfall and snowfall in California, and the rather, beautiful weather, but not great for generating surf, especially in the Gulf of Alaska. Right, putting this into motion, we see as we get into Monday, the trough in the Gulf continues, the trough off the Kuril Islands moves east, but sort of generally weakens some, and you end up with this sort of a broad trough off the Kuril Islands as we get into Tuesday, and the second trough fading in the Gulf of Alaska. Winds start dying in the jet sort of spreads out a little bit, but still consolidated the whole way to a point north of Hawaii and maybe even a little bit beyond there, and then things continue. Now notice the split here off of California getting more pronounced, only supporting high pressure there as we get into Wednesday. Then Thursday, same sort of deal. New trough is forecast forming off North Japan, being fed by 140, 150 knot winds, looking pretty decent. And we're out to Friday. Basically the same pattern. Broad trough over the Kuril Islands. It pretty much says all the action here is in the significant broad gale action is west of the dateline. But notice a new trough on Saturday starting to build in the Gulf of Alaska, falling down the Canadian and U.S. west coast, and then pushing inland Saturday night into Sunday over northern California. There's a little bit of hope there, maybe, just maybe, for a local gale and maybe some weather into California. Nothing too significant, but see the same pattern holding. Consolidated jet in the west, heavily split, big high pressure in the east, and then whatever does happen, really the storm track drives over the Pacific Northwest and then into the interior U.S. from there. And here we are a week from now, Sunday night, and still same pattern basically holding. So let's take a look down in the atmosphere at the surface. Surface level pressure, surface level winds. As of Sunday evening, little low pressure off of British Columbia, producing 45 knot winds. Probably getting some traction on the ocean surface, and we saw there's some seas off here, nothing huge. Here's that stubborn high pressure system again. It rotates clockwise, sending a north flow down the California coast, trades into the Hawaiian Islands. A broader developing, it's sort of a complex gale, but it's really this portion of the gale here. Counterclockwise flow, 45-knot winds here aimed down at Hawaii. These winds all pushing from the southeast up to the northwest, targeting only the Aleutian Islands. And then the third gale developing off of Japan with 40-knot west winds. Put this into motion, and basically the gale over the Pacific Northwest moves inland by, here we are, Monday morning, nothing left of it. The gale, a new gale, sort of trying to organize, is really remnants of the Dateline gale, quickly moving to the east, fading with 40, 35-knot winds, and the Japan gale pushing off 35, maybe 40-knot winds. And then we'll go another 24 hours out. Really, only the Japan gale is the only thing left by that time. 30, 35-knot winds over a broad area. That's capable of generating, there's a little pocket of 40-knot winds. I'm just guessing roughly, 23, 24-foot seas, maybe a little bit more because it's over the same area for a longer period of time. And that continues into Tuesday night and into Wednesday. Now, this is new, a little patch up here, maybe a redevelopment of what was left of the Dateline gale on Wednesday, 45-knot winds, but lifting quickly to the north. And now we're into Thursday, and things really kind of quiet down. Yes, a broad gale is forecast here, but only with 30, 35-knot winds, lifting fast to the north on Friday night. And then, this is stronger than the previous run of the models. 50-knot winds out of the west, almost southwest on Saturday. And, okay, we'll call it a gale in the North Dateline region installed there, theoretically, on Sunday, and then quickly moving inland. Also notice a small gale forecast developing in a trough off of California on Sunday, a week out, with 40-knot winds sweeping south. So, some hope there. Let's go take a look at the effect of these winds on the ocean surface. First off, we're going to go a little bit back in time because we know there was a gale that formed on the North Dateline region on Saturday. That's yesterday. It had some decent winds, small area, 30-foot seas building on Saturday night to, max seas over the whole domain, 36 feet right there. Okay, at 44 north, 178.5 west. Okay, and then there's the new system developing off the Pacific Northwest. All right, let's go take a look at the forecast. And then as we got into Sunday afternoon, seas built to 37 feet and pretty much held 36.8 feet. So that's about the peak of this one. At one point, this system was forecast to be a little bit broader. Seas were up to 44 feet, but the models just, it didn't materialize. If that would have happened, we would have actually had a pretty decent pulse of swell pushing into the Hawaiian Islands and the U.S. West Coast. Now we're down to more just kind of moderate utility class surf, if you call 10-foot utility class, but on the big wave scale, that's about all it is. All right, so Sunday evening, gale moving into British Columbia, Vancouver Island, another gale over just east of the Dateline with 36-foot seas, another gale off of Japan, 33-foot seas. They all push off to the east. This gale, the North Dateline gale, dissipates as we get into Monday night, but then tries to reorganize up in the Gulf of Alaska, 26, 27-foot seas. The Japan gale, more interesting with 20, 22, 24, we'll say 27-foot seas approaching the Dateline, and up to 28, and then 30 feet as we get into Wednesday morning. So a second pulse of swell expected for Hawaii, and much smaller for the U.S. West Coast, given the long travel distance. I mean, from the Dateline, it's, 2,600 nautical miles. So whatever reaches the U.S. West Coast will be, inconsistent and not nearly as much energy as what the Hawaiian Islands will see. All right, so we move into Thursday. Things definitely start settling down. We know there's not a whole lot going on. Some broad gale forecast up here. Let's see what happens. According to this, just really nothing. All the energy is aimed almost at Alaska. Oh, and of course, the little gale off California. A week from today, don't know if we believe it at all. It would be great. Swell-wise, yeah, I mean, it's supposed to make seas in the 26, 27-foot range, but it'll just probably be a windy mess if it even happens, and not a whole lot is expected in terms of surf if it happens. All right, let's keep going. So we're looking south in February. Unbelievably early to have something to look at in February. Typically, it's not till mid-March, later part of March, that you start looking this direction. But anyway, on Sunday, the 16th of February, a gale started developing southeast of New Zealand and built with a small area of 33-foot seas aimed to the northeast, lifting pretty well to the northeast, continuing into Tuesday, and then fading out. Swell from this system is in the water pushing north, not towards Hawaii, but towards the U.S. West Coast, and expected in, I believe it's about Tuesday or so. Nothing huge, like 3 foot, probably top spots. You can see some sets in the head-high range, something like that, but nothing just the same, and especially for Southern California, that would be something of interest. And then even more interesting, on Saturday, another small gale developed. Now this is tiny, produced 29-foot seas aimed north, and then up to 35 feet into Saturday afternoon, into Sunday evening, down to about 33 feet, and then started fading from there. But still, another small pulse of swell, again in the, we'll say, waist to chest high range for good spots in Southern California, is expected, pushing to the north. Not so much for Hawaii. Hawaii's at like 158 west, so back over here, and most of this energy was all pushing off in this direction. So nothing really for the islands. Then we'll take a quick look further out for the southern hemi, and there is yet another gale forecast, but it is 26-foot seas, all aimed due off to the east. You really need, even more, higher, but again, good for Peru, Chile, not good for U.S. We need systems pushing off to the northeast. We'll just roll this on out. Another series of gales are forecast pushing under New Zealand starting next weekend, but all falling southeast and not doing anything in terms of producing swell aimed up at the northern hemisphere. So nothing beyond the two swells that are already in the water is forecast. Let's take a look at the wind forecast for California and Hawaii. Here we are Sunday. We'll put it out to 18 Z's, so that's late Sunday morning. North winds along the California coast, 15 knots, 20 knots. That's about right. That's what we saw. It's pretty junky and blown out and pretty much a mess, at least in exposed breaks in Northern California. Hawaiian Islands, light trades, not even trades, just like southeast winds, 10 knots on Oahu. Good, clean conditions from what we can tell. So we get into Monday. That situation along California continues. Pretty strong north winds, northwest, 15, 20 knots. Trades for Hawaiian start ramping up as we get into Tuesday. Out of the east, 15 knots. High pressure building right in here. You can see it, the clockwise flow around the high. As we get into later Tuesday, into Wednesday, the gradient moves to Cape Mendocino for California. So light winds from, generally light northwesterly winds from Point Arena southward. Trades really solid in Hawaii, 20 knots on Wednesday. And then we get into Thursday, pretty much the same situation for California. Probably wind swell, almost like a summertime wind swell type pattern. And then solid trades. Now notice the trade winds out of the northeast, extending the whole way from California over the Hawaiian Islands. So east wind swell there to go along with whatever swell comes from is in the water coming from the northwest. Get into Friday, winds completely die along California. Notice high pressure, solid 1032 millibars just north of Hawaii. Again, driving trades there. California at least gets a little bit of a break. Low pressure starts building as we get into Saturday over Vancouver Island. You see high pressure building. Look at the trades, 20-25 knots, just nuking over the Hawaiian Islands. Though a relatively light wind pattern over California. But then we get into Sunday. This is the 18. This is the 12Z run of the model. The low starts building off of Cape Mendocino. Probably south winds ahead of that right in here, but behind that with high pressure at 1038 millibars, that's very strong. That's going to set up a strong north gradient along the California coast, and by Sunday evening we're talking 35 knot winds solid all along the North California coast, and whatever southeast winds there were in Central California, that's all going to be wiped out by sunset too. And of course trade still just very firm, 20-25 knots over the Hawaiian Islands. So California to get a little bit of a break latter part of this week, but then the wind machine starts right back up. And trade's pretty solid once they start building in for Hawaii, solid and not changing. Let's take a quick look at precip potential for California. Here we are Sunday, and we're just going to blast through this. You can just see high pressure in control. No real sign of low pressure anywhere near the coast until you get into Saturday, and that low starts building up north here and falling south. There it is. Rain, maybe, just maybe a little bit of rain, and the whole sweeping down the California coast. A little bit of snow, maybe for the central and southern Sierra. In fact, let's go take a look at the snow models. Here we are. So low pressure pushing into the Vancouver area right now, producing snow, as you can see, radiating, moving inland Sunday night, even into Idaho over here, Jackson Hole area, and then maybe a dusting down into Utah. Probably not a whole lot. That system fades out. We wait for another system. Small one pushes into the Whistler area, and that fades. Maybe a dusting for interior Pacific Northwest. And then when's our next system coming? We're looking for it. There it is. Starts building in on Saturday into the Pacific Northwest. And, okay, here you go. Now, here's the little bit of California snow, theoretically starting Saturday afternoon. Maybe, just maybe. Now, look at this. It slides down the coast and mostly misses. Even at Tahoe, it's south of there. We'll say Kirkwood and places south of there. And then, in, of course, interior Colorado, Utah looking to get some snow, and yet another system for Whistler. I mean, Whistler has done really well. Even Jackson Hole did quite well this season, but now the focus, I mean, the line almost seems like North Oregon, Washington, you know, and then driving down inland, we're out 240 hours, and that's that. Snow forecast for Squaw Valley, virtually nothing for the next 10 days. This is the bottom of the resort, temperature-wise. This is the top of the resort. Above freezing temperatures for almost a week, then dipping to cold for, what is that, maybe 2 days, and then back to warm again. It almost looks like we're setting up for spring conditions. Kirkwood, much the same situation, maybe a couple of inches of snow next weekend at best. Temperature-wise, yeah, they're higher, but still nearly above freezing the whole way to the top, or at least halfway up the mountain over the same week period, a 2-day break, and then back to warm temperatures. And Mammoth, theoretically doing a little bit better, maybe 8 or 9 inches of snow. But again, warm temperatures until the snow comes, and then just barely cold down to the bottom, and then back to warming up. So whatever fresh snow there is, if it happens, there's like a tiny little window to get it, and then it's back to melting and spring conditions. All right, let's go take a look long term. What's going on with the Madden-Julian Oscillation and El Nino, and we're even going to talk a little bit about the PDO as well. All right, first up, the Madden-Julian Oscillation, a periodic weather oscillation that traverses the whole planet on the equator, moving from west to east. When in the active state, it helps transport energy into the jet stream and help feeds the storm track. When in the inactive phase, it does the exact opposite and basically steals energy from the jet stream and results in a split pattern and lack of storms. All right, so looking at the Pacific Ocean. This is the West Pacific here. This is the East Pacific here. This is the equator there. Dateline 180 west right there. This is data from the TAO buoy arrays, a series of buoys strung across the equator used for monitoring El Nino. These are 5-day average winds. Okay, so it's not exact, but it gives you a rough idea of what's going on. Winds pushing hard from the east. We're just looking at the arrows over the East Pacific, and then continuing pretty solidly east, even over what we call the Kelvin wave generation area. This area from 135 east to 170 west, 5 degrees north and south of the equator. When we have west winds or west anomalies here, that's a good sign of the active phase of the MJO. When you have east anomalies like what we have right now, yes, there's a little bit of, well, this is actually east winds, little bit of west winds south in the southern Kelvin wave generation area, but you need a pretty good solid boost of west winds for a reasonable period of time, let's say a week or 2 weeks, in the Kelvin wave generation area to create a Kelvin wave. And a Kelvin wave is, of course, a ball of or pool of warm water that starts getting pushed east by these westerly anomalies. And it takes 3 months for those warm waters to make it not on the equator but under the equator. They erupt off of Ecuador, and then if you get successive Kelvin waves, that's how you can start seeing signs of El Nino. All right, anomalies, the differences from normal for this time of year. Yes, we have east winds. They're blowing pretty hard. But looking at the arrows, they're not excessively strong from the east or the west, so pretty much normal. You get into the Kelvin wave generation area, you see normal winds north, but south of the equator, winds are still a little bit stronger, a little bit stronger than normal from the west, suggesting some form, maybe the lingering last little bits of the active phase of the MJO in that area. Wind anomalies for the past 5 days or so. So this is 850 millibar wind anomalies. That's fancy words for up about 4,700 feet in the air, but a good proxy for what's going on at the surface. There's South America, Central America, Australia, New Guinea, Kelvin wave generation area right in here. And we see the arrows coming from the west in oranges and red, meaning westerly anomalies. Active phase of the MJO, more than likely 17th of February. That continued on the 18th, the 19th, the 20th, and then getting weaker on the 21st, suggesting the fading active phase of the MJO. What's the forecast for the next week in the Kelvin wave generation area? So this is the whole planet on one chart. The date line, right down the middle of the chart, Kelvin wave generation area from 135 east. So consider this the far west Pacific. The far east Pacific would be about here where Ecuador is. This is on the equator. Kelvin wave generation area between that tick mark and that tick mark there. You just draw a line right up through there in your mind. Okay, and this is time here. So you see in February 13th, 18th, we had a little spurt of the active phase of the MJO, the oranges and the purples, westerly anomalies. Here's where we are today. Those westerly anomalies pretty weak, and the forecast is getting weaker with east anomalies building in the far western Kelvin wave generation area and easterly anomalies over east of the Kelvin wave generation area. So it does not look like the active phase of the MJO is going to resurge the way some models had predicted last week when we had our presentation then. Let's dig a little bit deeper. All right, outgoing long-wave radiation is a 2-week model, another component of the MJO, basically fancy words for cloudiness. Where you have blues, that means more cloudiness, that means the active phase of the MJO. Where you have oranges, that means less cloudiness, more sunlight reflectivity off the ocean surface, and the inactive phase of the MJO. The equator is right there, South America there, New Guinea there, Kelvin wave generation area, right about in here. Weak active phase of the MJO in control at the moment and fading as we get 5 days out. And according to the statistic model, pretty much out of the Kelvin wave generation area, we'll say 8-10 days from now. And then the inactive phase building into the western Kelvin wave generation area 2 weeks from now. But the GFS model, that was the statistic model. The GFS ensemble model says basically the same thing starting out, but then magically all of a sudden the inactive phase builds modestly over the Kelvin wave generation area at 8 days out and then continues into 2 weeks out while the active phase builds over the maritime continent and starts seeping into the West Pacific. So here you go. Here's the statistic model forecast, the days 6 through 15. And here is the dynamic model forecast. It's like they've flipped. So there is definitely a difference in the two models. concerning the forecast 2 weeks out. Let's try to understand that a little bit more. Phase diagram charts. So we're looking, this circle here, assume you're looking down on the North Pole, right? And the MJO travels on the equator from west to east, over the Indian Ocean, over the Maritime Continent, through the West Pacific, under the United States, across the Atlantic, over North Africa, and back to the Indian Ocean. Where the heavy dot is where the active phase of the MJO is. So basically, we'll call it the East Pacific. And the further away this dot is from this circle, if it was more out here, then it's strong. So a very weak active phase. Per the statistic model, the active phase, there's 3 different sort of runs or branches of it. They all are the same, saying the active phase of the MJO is supposed to be in the far west Indian Ocean 2 weeks from now, and very weak. Now, here's where the rub is. The dynamic model says, no, the active phase is to race off to the east and be over the Maritime Continent, sort of backtracking somewhere between there and the Indian Ocean 2 weeks from now, but still very weak. So a difference in position, one says the far west Indian Ocean, the other says the far east Indian Ocean, but in both cases, the MJO very weak at that time. The upper level model, this is a statistic model. As expected, shows the active phase of the MJO. You actually see it over in the Atlantic this time, getting ready to move into Africa. Now, this is the upper level model, and it's about a week ahead of what's happening back at the surface. So the active phase is probably somewhere, just inside of Central America, something like that. Anyway, and the inactive phase building over the Maritime Continent and continuing east, making its way across the Pacific the whole way into March 24th, so almost the end of March, with no active phase at all expected for the Pacific during March till you get to like the 24th, the very end of the month there, and then the active phase weekly is supposed to build into the Pacific and sort of filling the Pacific at the end of the model run on April 4th. Now, so that basically suggests that the whole month of March is to be a write-off in terms of storm production and just not particularly great for swell production either. Here's the CFS model. So this is out a month, and this is, again, the whole planet on one chart. Kelvin wave generation area starting here, going over to about here. Work your way up. Here's today's date, February 22nd. And you see, so the oranges and the reds are westerly anomalies. So westerly anomalies in the Kelvin wave generation area, this solid black, that's the active phase of the MJO, but it's very weak. Like, look at, here's a previous active phase, and even that was pretty weak in terms of just being active. Westerly wind's pretty strong associated with it. Anyway, so we're going to call this, we're in the active phase of the MJO, but over the next 1-2 weeks, it pretty much dies out. Even westerly anomalies associated with the active phase fade out. We move to a very kind of a neutral-ish, weakly biased westerly wind pattern at the end of March. Tiny little inactive phase forecast there. We're not even going to call it that. Otherwise, pretty much neutral anomalies, so not a strong MJO signal at all for the next month. All right, and then finally, the 3-month CFS forecast. Not believable. Never believe a model out 3 months, but it's always good to sort of tease ourselves and see what's going on. So this is the same deal. Whole planet on one chart, Kelvin wave generation area from here to here going up the chart, but this is past performance down here. This is the forecast moving forward. Just eyeballing it, you can see westerly anomalies forecast continuing in some fashion the whole way from now until the end of May. That's good news. Now, here are 2 strong previous active phases of the MJO. We don't see anything that strong. We do see sort of a kind of a pretty big target here in late March, but in early April. But by then, we would think the storm track would be so weak that even if you did get a strong active phase of the MJO, it's not going to do anything for storm production. Let's overlay the MJO here. Here we go. It says we are in a weak active phase of the MJO, the solid contour here, continuing till about March 7th or 8th, something like that. Then we go into a weak inactive phase, but westerly anomalies continue. And then finally, as we get into March, that stronger active phase of the MJO with westerly anomalies. So maybe there's some hope in there somewhere. That would be from mid-March till mid-April. I don't know, just given the way the year has gone, that just Doesn't seem like it's going to materialize to be what it looks like in this chart. And then beyond that, moving steadily into the inactive phase of the MJO. Let's overlay the low pass filter. Here you go. The good news here, this solid contour is like a low pressure bias, suggesting not El Nino, but an El Nino-ish like pattern in the Pacific Ocean. It has been fluctuating somewhere around this mid-April time frame. You know, one run of the model, it kind of almost dies out. The next run it holds, but it's been getting more, as we get closer, more and more focused on the low pressure bias continuing in the Pacific. So that is good news. High pressure bias, at least according to today's model, holding solid in the Indian Ocean with easterly anomalies there. That has been what was feeding the strong drought in Australia, and it appears that is still going to be the case as we work our way into May, which would be winter in the southern hemisphere. So let's move on and talk El Nino, La Nina. One of the components of El Nino, La Nina, commonly known as the El Nino Southern Oscillation, is subsurface water temperatures. During El Nino, warm water in the West Pacific sloshes east. During La Nina, warm water gets pushed off to the west, driven by unusually strong trades, which is sort of like what's going on right now. But the good news is at this moment, and normally you get cold water evolving off of Peru and Ecuador. Right now, we have a pretty warm regime across the whole subsurface Pacific. So this data from the TAO buoy arrays, again, these are the anchor lines on the buoys strung across the equator. The X's are the sensors. We use a model to connect or to fill in the gaps of data to build a profile of where the balance of warm water is. Clearly, here, this is centigrade, 30 degrees centigrade, so 30 times 1.8 plus 32 gives you what the temperature would be in Fahrenheit. But anyway, 30-degree isotherm, pretty weak in the far West Pacific. 29-degree isotherm, unchanged from last week at 173 west, brick wall. The 28-degree isotherm, also unchanged at about 162 west. And then the 24-degree isotherm, still pushing pretty solidly into Ecuador, again highlighting warm water over the balance of the underneath the equator across the whole Pacific Ocean. It is anomalies, differences from normal for this time of year that really tell the picture, though. Okay, so West Pacific here, East Pacific here, and what do we see? A ball of warm water at 3 degrees centigrade, extending from the date line all the way to, where is this? Okay, there is 125 west to 1, right there. There's the leading edge at 125 west. So this is a Kelvin wave. It was driven by successive active phases of the MJO, westerly anomalies blowing. In fact, we'll do it up here. Here's actual temperatures. Westerly anomalies that blew over the West Pacific Ocean took this warm water here, forced it to depth, and then it starts making its way across the Pacific. And here it's doing that. Now, we had thought this was stalled, but now in the past couple of days, we see it's actually starting to make some eastward momentum, so that's good. So this is not going to be a stalled Kelvin wave, though we don't think it's going to be particularly energetic. It's just going to take its good old time making its way across the Pacific. Here's a different model using the same data, but it shows the same basic picture. We've got 1, 2, 3, 4, 5 contours, 1, 2, 3, 4, 5. So 3.5 degree centigrade anomalies in a pretty broad pocket here, pushing east to about 120 west. And then this is another Kelvin wave. So this is Kelvin wave 6, this is Kelvin wave 5, but we've had this warm water just steadily seeping into Ecuador. Notice as it starts getting compressed here, the temperature actually rises a little bit. This looks like it's about 4 degree anomalies pushing into Ecuador, but still nothing, super substantial, and you'll see why in a minute. And yet one more confirmation on subsurface temperatures. So this is JSON-3 satellite data. You strip out the waves, strip out the wind waves, strip out the tides. You see there's a bump on the ocean surface, 5 centimeters. Basically, if you have warm water at depth, it kind of expands and it'll push the ocean surface up. And the satellites are so sensitive, they can see a 5 centimeter bump on the ocean surface or sense it. And you see that continues from just east of New Guinea over the date line and basically pushing the whole way into Ecuador, suggesting warm water depth over this whole area. Not super strong, but still warm water. That does not suggest at all La Nina. And if on first glance you go, gosh, it seems like El Nino is either organizing, trying to organize it, or whatever. But we know that really not to be the case because, well, you just look at the surf pattern this year and look at the rainfall pattern. So it's sort of this hybrid thing where it's sort of like an El Nino, but not, and really more like La Nina. Upper ocean heat anomaly trend. Okay, this is the West Pacific here, East Pacific here, and basically you can use this chart to just watch Kelvin waves make their way across the Pacific. I think this was Kelvin wave number 4 a year ago. Westerly anomalies take warm water, push it. You can see it. The reds are warmer normal temperatures, pushing into Ecuador here in the May-June time frame. Then in over last summer, we had 2 Kelvin waves and they stalled. Remember we talked about this? They didn't have much momentum and they just like died. They made it to a point south of California on the equator and no further. And instead we got this cool water regime that's set up down in the South Pacific. And it kind of looked like La Nina. But then magically as we got into fall, another westerly wind burst, another Kelvin wave form. Took 3 months. I mean, it developed in September. Finally pushed into Ecuador in the Christmas time frame. And now here is Kelvin wave number 6. It did the stall thing here, the first push of it, but now it appears, it appears to be on the move. This chart says making it to 125 west, and we think it's going to keep on going from there, but still there's no expectation that we're moving towards El Nino at all. These Kelvin waves are weak. They have a difficult time breaking it any further to the east than maybe the point south of California on the equator. And just kind of, it's better than no Kelvin waves because then you'd be in La Nina, but it's nothing really great at all. So then we go look at surface water temperatures, all right? And this is kind of a convoluted way of looking at multiple pictures, but this is sort of the high-res view. You see off of Peru, light warm waters up into Ecuador there in that area. There's some overlap here, Ecuador, and the whole way up into Mexico above normal. The equator is right there, that line. You see the warm water for the most part is north of the equator, and there's actually cool water from the Galapagos are there. So we'll say just west of the Galapagos out to a point 140 west, about halfway to Hawaii, and then warm waters take over. The other thing to notice, and this has been the real issue, cool pool off of Peru. It's held last summer, all this winter so far, and now cool water developing off of the U.S. West Coast. All this smells of stronger than normal high pressure there, creating upwelling off of California, and in high pressure rotates the other way south of the equator, and high pressure creating upwelling here. If you have high pressure north and south of the equator in these regions, that certainly smells like La Nina. Now, not strong, but sort of gives you the hint that maybe it wants to come on. That said, we're looking at the 7-day trend here, just 7 days. You see the oranges. Yeah, a little bit warm, a trend towards warming off of Peru and Ecuador. But you also see a couple little interspersed pockets of cooling in there. And then, supposedly some warming off of Mexico. But basically, a neutral pattern, lightly biased warm, if anything. And then the overview, much like what we saw before, light warming off of Peru. Stronger warming, but not very strong off of Central America. There's that little pocket of cool water, and it's been there for 2 weeks now, on and off in varying degrees on the equator. Much more warming off here, but still nothing solid. If we were in El Nino, you'd see like a triangle that goes like this, and it would all be like deep reds like that, or even stronger than that, all in here. We're not seeing anything like that. I mean, this is maybe half a degree at best, so it's almost noise level. At least it isn't cooler than normal, but it's certainly not significantly warmer than normal. The temperature trend in the Nino 1.2 region, this is the area right up there along Peru and the Galapagos and Ecuador. Today, 0.044 above normal, and you can just look at the trend. It's been hovering neutral there for, since December, basically. Now, this is not the official El Nino monitoring region. This is sort of a noise region, but when you see Kelvin waves impacting Ecuador, you would expect to see some spikes in here, and you're not seeing any of that, suggesting that these Kelvin waves are just very weak. They're barely nudging the needle, not doing a whole lot, not a lot of momentum behind them. That said, in the Nino 3.4 region, the official El Nino monitoring region, that's basically from 120 west to 170 west, so a point south of California on the equator, the whole way out to the date line, almost to the date line, 170 west, 5 degrees north and south of the equator. Temperature today, 0.337, third of a degree above normal, and, has been holding there to maybe a half a degree since December. Now, to be El Nino, you need to be half a degree for 5 consecutive months, so that would be up in this range. And we haven't even hit that level, but maybe 1, 2, 3 days in the past 3 months, something like that. So no hope of El Nino in any of this data, but at least it's not down here in negative territory, suggesting La Nina. All right, so what's the atmosphere doing? I mean, the ocean's kind of like a little bit warm, but not really. Is the atmosphere sensing anything one way or the other? I mean, so typically the ocean interfaces with the atmosphere. The atmosphere can drive the ocean can drive the atmosphere. They work together and they can reinforce each other, either going negative or going warmer. Right now, so this is the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When pressure is lower in Darwin consistently for long periods of time, that's suggestive of the active phase of the MJO. And if it's really, for months, then it's suggestive of El Nino. The daily number, and you'd want to see this number be negative. Today it's positive at 5.14. Not very positive. And you look down and you see, we were negative for a little bit of a run here, but you just sort of go back through the past month and it's been noodling around, not either strongly positive or strongly negative. You get some of the noise out of this by doing a 30-day average. That sort of, you can pick out the active or inactive phase of the MJO from that. Today, minus 2.83. Again, not strongly active or inactive, suggesting that the MJO has been very weak for a while now, and we've all seen that watching this week by week. The models say, here comes the active phase of the MJO, and then it comes, and, you get a little uptick in storm activity, but it doesn't have a major influence. So the atmosphere in general, there's just not a whole lot going on. 90-day average, minus 3.65. If you want to see El Nino, this needs to be down about 15. If you want to see La Nina, up at positive 12. Again, we're just noodling around. We're looking at the numbers here. It's actually getting, generally, it was down at minus 5.87 a month ago. Generally getting more neutral, which suggests generally the atmosphere is only getting weaker, not more energetic. So that doesn't do much for the jet stream, that doesn't do much for the storm track, and suggests that we're kind of dug into a pattern right now, and it's not a real favorable pattern. So here we've graphed out the 30-day moving and Southern Oscillation Index. Today, here we are at minus 3 or something like that. You can actually see the spikes in the active phase of the MJO, that is when the SOI drops negative, then the inactive phase. So you can sort of try to pick out what the trend is, and you can sort of see the line generally heading up, meaning the active phase of the MJO is getting steadily weaker, which is not a good sign. Back here it was actually positive, which suggested La Nina back in 2018 or so. And then we kind of went negative in 2019, suggesting, hey, maybe we're moving towards El Nino, but now we're moving back into this sort of neutral, anemic, lack of energy, low excitement kind of pattern. The hope is that we don't move into a La Nina pattern, but we don't know for sure. But let's go take a look at one model's projection. So here's the Cfs model projection. It is unchanged from multiple weeks now, suggesting a full-on dive into La Nina as we get into summer and spring. Summer and fall. But we are in what is known as the spring unpredictability barrier. That time from we'll say somewhere in early March to late in May. The models have a very difficult time sorting out what's going to happen in the fall and the winter beyond that. So this is the CFS model, sea surface temperature forecast for the Nino 3.4 region. The official El Nino monitoring region says temperatures are 0.6 of a degree above normal. We know they're really about somewhere down here, about 0.33, something like that. Either way, temperatures falling, suggesting the development of La Nina, dead neutral as we get into mid-May, and then falling deeply to a degree and a half to almost 1.6 below normal as we get into next fall. The question is that a minority opinion, or is that really where we're going? Let's take a look. So here is the sum of all models, and you can see there's a whole list of models here. I don't know, was there 20 or 25 of them? Statistic models, dynamic models. All right, the CFS model is the green line on this chart. So it is an outlier, but also notice there's one even more negative. The NASA GMAO model says even stronger indications or deeper La Nina. And this one other model here, this looks like the, I can't quite tell. But anyway, you can take a look at it and see for yourself. So the models are sort of split, but the dynamic models seem to be pushing more towards La Nina. The statistic models more hanging right around dead neutral. We can go down here and look. Oh, here we go. You can look at the actual output from each one of the models. This is for like February, March, April. They do it in 3-month bins, but I'll just say February, March, April, May, June. You get the idea here. Down here, the average of the dynamic models for each month suggests, well, we're half a degree above normal now, and we're going to be moving to basically dead neutral or maybe a third of a degree below normal. Whereas the statistic models say, yeah, we're a third of a degree above normal, and we're just going to move basically to dead neutral. So the jury is definitely out on what's going to happen in regards to either the formation of El Nino or La Nina. The consensus, the CPL consensus, that blue line suggests basically, no, just hovering somewhere around normal as we get into next fall. And if that happens, we'd be very happy. We do not want to go into La Nina. And statistically, I suggest, the thought is, you typically don't go into some deep La Nina unless you're coming out of a pretty decent El Nino. And we haven't been in El Nino for a while, so we have no reason to believe that, going to La Nina, or at least some deep form of it, is going to happen. Though the concern is this cooling water off of Peru and off of the U.S. West Coast. It's not unusual. I mean, that's pretty typical for this time of year. But still, it's been persistently there, and it just doesn't want to give up the ghost. So, who knows? And then finally, the Pacific Decadal Oscillation. And we're not looking at forecasts here. This is just what has the trend been. Right, so what's the PDO? It's basically like a long-running El Nino, La Nina sort of thing, but instead of just running for a year or two, it runs for 15 or 20 years. When in the warm phase, it's basically like a long-running El Nino. So back, this is 1980, the reds are all positive numbers. Yes, you see it goes negative, but back in 97, 98, we had a massive El Nino, and right after that, boom, we fell into like the Ice Age. And from 98, the whole way through till about 2014, we think we were in the cool phase of the PDO, whereas before we were in the warm phase of the PDO. And then we think, just maybe, January 2014, we moved into the warm phase of the PDO again. Now, that doesn't mean you stay warm the whole time, because you see here, there were down spurts, and you can go back in this record and play with it, find it on the website. But basically, we think that we are in the warm phase of the PDO, and this is just a little negative dip. I mean, here's the real, the real cool phase, or the cool side of the PDO looks like. You notice even here during the warm phase, we had a pretty good negative spike, and we're nowhere near that. So we're just kind of in this like, yeah, we're in the warm PDO, we think, but for the moment, biased a little bit cool. We suspect we're going to pop back out of this at some point fairly soon. All right, so to wrap things up for right now, Series of storms, nothing strong, but some swell is forecast coming from the northern hemisphere. 2 or 3 small little systems. Main focus on Hawaii, but the U.S. West Coast to see some action from it too. Unfortunately, a bit of wind for most of California. Southern California, more protected, but also more protected from swell. Also, though, 2 southern hemiswells, nothing huge, but they're in the water pushing north. Again, favoring Central America on up into Southern California. Northern California, yeah, might see some of it, but a lot of it will be masked by other swell. Long term, yeah, maybe a hint of some rain and some snow, but not much. I mean, just the whole winter, other than the January timeframe, has been focused north of Northern California. And for now, we're really saying the Whistler, Washington, kind of area is the main target. If you're going to get something, you better get it pretty quick, though, because we suspect as soon as this active phase of the MJO wraps up in, we'll say, March 15th or so, we're going deep into a springtime pattern, and that will be pretty much it for the season. Long term, all right, yeah, we think we're not going towards El Nino. Are we going to La Nina? Hard to say. We're in the springtime unpredictability barrier for the moment, so hard to tell. We're going to go with on the side of probably moving to a neutral pattern, but the deep signs from the CFS model suggesting a move towards La Nina and the trend towards that last summer leaves us a little bit concerned still. So we're not going to rule out a move to some sort of La Nina next year, but we're hoping that's not the case. All right, so if you enjoyed the video, be sure to click the thumbs up. We'd appreciate it. If you haven't subscribed, down on the right, click the subscribe button. You'll get a notification when we update the forecast, typically on Sunday evenings. And if you don't want to subscribe, that's fine too. You can follow along. All this data is available on Stormsurf.com. You can follow along wave models, weather models, buoys, all kinds of stuff, so you can keep up to date, up to the minute on what's going on. You can watch these swells coming in through the outer buoys into your local breaks. You can get wind forecasts, all that kind of stuff. So check it out, Stormsurf.com. Otherwise, we'll do this again next week. Same time, same channel. Thanks for watching.